So I'm going to talk about the jet stream. That's just what I've just written my book on. So thanks very much to everyone in AUP who has supported this project and helped. It's been very much appreciated. So this is a little picture of the jet stream. But let's talk about some other things first. So I don't know if people have heard messages like this or quotes like this in the past, that we can have even in Scotland we can grow palm trees thanks to the Gulf Stream keeping us warm. Have people heard things like this? These are this is kind of the nicest picture I could find of palm trees in Scotland. I think it's fair to say that a lot of them look quite weather beaten, right? These are the kind of the best preserved ones. But it's true, we're a lot in winter. We're a lot warmer here than we kind of should be, right? So if you compare Scotland, for example, to other places of the same latitude, right? Scotland's at the same latitude as Labrador in northern Canada, and so there's a huge difference in temperature between these places. So there is obviously something that's keeping Scotland warmer than it should be. And so the Gulf Stream was the Gulf Stream itself was popularised by Matthew Maury, this guy over here. So he's often called the kind of father of oceanography. He did a lot of really incredible stuff. He was the first person that really kind of systematically collated lots of data from all over the oceans to come up with kind of charts of where we should expect ocean currents and temperatures and so on. So we did a lot of great kind of data work collecting things, and he really supported this idea that it was the Gulf Stream that kept Europe warm given its latitude. Unfortunately, Henry Stommel is another very, very famous oceanographer, much more recent, kind of mid 20th century. And Stommel had this to say about Maury. I cannot suppress the view that Maury was very much confused concerning fluid dynamics. So Maury did a lot of great things, but a lot of things he got quite wrong, unfortunately. This is a picture of the Gulf Stream. Okay, so the Gulf Stream is an ocean current, right? So it's a current of warm water. The colours here are basically how warm the water is, and so you can see North America here and Florida. And so the Gulf Stream is this kind of very strong warm current that comes along, hugging the coast of North America till it gets to Cape Hatteras and then kind of breaks off into the Atlantic. And there is some amazing fluid dynamics going on here, right? So I guess my day job is fluid dynamics and how it applies to the ocean and to the atmosphere. And there's some incredible things going on as this thing swirls around and breaks up into eddies and so on. But one thing that's hopefully fairly obvious from this is that it kind of stops about here, right? The Gulf Stream, the Gulf Stream is a hugely, it's a very warm body of water, but it doesn't really get anywhere near Scotland. Okay, so the Gulf Stream is definitely not what is keeping Scotland warmer than it should be. Okay, so we'll move on to somebody else. So I want to talk a little bit about a guy called James Glacier, who he's best known for his adventures in balloons. Okay, so he was a part of a group of kind of adventurous. I guess they're kind of today's like celebrity scientists, right? These are the celebrity scientists of the 1800s. So they would go up in hot air balloons or in gas balloons and take measurements of the atmosphere, because it was really unknown, what the atmosphere was made of, how it varied as it went up. There were lots of kind of things that today are part of kind of fundamentals of atmospheric physics that weren't known. So Glacier wrote a very nice book called Travels in the Air, which you can now get from the Royal Meteorological Society. They've re-released this recently. This is just a nice picture from it. So that's Glacier. He's kind of he seems as kind of a slightly kind of madcap character in a sense. Like you can see him here in the basket with all his instruments and things. and he had all these daring exploits. But he was a very serious scientist, right? So he was I think even at this stage, he was an FRS. He was a fellow of the Royal Society. Kind of later on in life, he went on to become president of the Royal Meteorological Society. So he was quite a serious and distinguished scientist. But he's best known for these kind of balloon exploits. And this is his kind of most famous trip. So this one was in 1862. So this is fairly early on, I think. This was like his fourth trip or something. He did a lot of trips with this guy Coxwell. Right, so this is Glacier. The caption here says, "Mr. Glacier insensible at a height of 7 miles." Okay, so this was this is him suffering from the altitude essentially, and this is Coxwell who he did lots of his travels with. And it's incredible actually what they did here, right? Because so the balloon took off from Wolverhampton, okay. I think it was about lunchtime in September 1862, and this is kind of a chart of where they went essentially. So as you go along here, we're going through time, right? So that I've marked in the blue line there about an hour. Right, so that's 1 hour of time gone by, and then on the side here we're looking at how high they got. Right, so this is like so where are we? That's 3 miles, 4 miles, 5 miles, and so the idea here is that there's kind of a sketchy bit in here. Right, they've got a nice solid line. Glacier took incredibly detailed measurements. You see all his kit here. He was taking lots of very detailed measurements as he went up, but essentially, at some point, he became insensible, as the caption says. So he basically passed out at about 5.5 miles up. And at this point, so Coxwell, who was basically the pilot, realised that there was a problem with the balloon. I think there was like a valve on top that would let the gas out, so that the balloon would go down again. And this valve got stuck apparently. So at the time when Glacier was passed out, Coxwell actually had to climb up into the rigging, and I think in the end he managed to release this thing with his teeth. Right, his hands weren't really working anymore, and so he pulled on this cord and released it with his teeth, and so it did come down again, right? And so you can see, by this point, then Glacier's recovered and started taking notes again. So he was incredibly dedicated. I'm not sure any of us scientists today would be quite this dedicated. I don't know. But they basically got. This is where Everest is, right, in terms of height, right? And so in the space of an hour, they went from Wolverhampton to above the height of Everest, right, which is incredible. I mean, people going up Everest these days acclimatise over like a month or something. So it's an incredible feat. And they were kind of exploring and just, they wanted to know what was up there, what the atmosphere was like, what it was made of, how it varied. And they noted things up here like. There was a really intense blue sky they've written up here, essentially because there's no, they're way above all the clouds and everything, and they're, with hindsight, they're essentially almost in what we'd call the stratosphere now, like the kind of the next layer of the atmosphere. But the reason I wanted to mention Glacier is essentially for this quote, which is in his book, and this came after a few trips. This is something he'd noticed after several trips up in the balloon. So there was one time in particular when he met a very strong wind from the southwest, okay, which was very warm. He was measuring temperatures and things as he went up. And so he talked about this southwest current being of the highest importance, for it goes far to explain why England possesses a winter temperature so much higher than is due to our northern latitudes. And so he was writing this, I think, in about probably about the late 1860s, 1870. And so Maori had been really popularising the Gulf Stream, and so he says, our high winter temperature has hitherto been mostly referred to the influence of the Gulf Stream, okay, which is the ocean. Remember the ocean current. And he says, without doubting the influence of this natural agent, he probably should have doubted that actually, but anyway, it is necessary to add the effect of a parallel atmospheric current to the oceanic current coming from the same regions. And he calls this thing a true aerial Gulf Stream. Okay, so he's essentially realised that there's once you go up into the air, there's a very strong current of air, there's a strong wind from the southwest that's bringing a lot of warm air over the UK, essentially. And so his aerial Gulf Stream is what we call the jet stream today, essentially. So there's people haven't really realised this, but I think Glacier has quite a claim to be one of the first people to have kind of discovered the jet stream. I don't think he really understood the extent of what he was looking at, but he kind of got a lot of the idea of its impact and what it can do. And actually, it wasn't until much later. So 2002, this paper came out, basically questioning the idea that the Gulf Stream was what was keeping Europe warm in winter. Okay, so with hindsight, it's incredibly late, right? We hadn't really. It's the kind of thing that scientists hadn't really thought about it, hadn't really concentrated on it properly, because it's not in danger of changing in a sense. It's not, it wasn't a kind of an urgent problem. But this team actually questioned whether it was the Gulf Stream at all, and they, I won't really show their work so much, but they really show that it is actually the jet stream and the shape of the jet stream instead, which is keeping Europe warm. So maybe I'll just look at a couple of pictures of now. So these are just pictures from the web. You can get these if you go to earth.nullschool.net. You get some amazing. This is kind of animated, right? When you go on the web, it's all kind of swirling around, and you can basically see what the weather patterns are like globally, today, over the last few days, and also forecasts of the next few days. So these are some pictures I took. I grabbed just of Saturday morning, just because it was an interesting kind of period. So what we're looking at here is basically where you can see the UK here and Europe and North America, and all the lines are basically showing the wind, right? So where you've got lots of lines and where you've got kind of reddy colours, that's where we've got a strong wind speed. Okay, so you can see all kinds of things here. This is a cyclone out here, so the air is spinning around like that. And the thing that's particularly interesting is this big kind of pulse of air that's moving up here, right? So this is our southwesterly wind, right, bringing air up in this direction. So this picture is basically quite near the ground. It's about 1 kilometre up probably. If we go a little bit higher, we can see the same thing really. We can still see our cyclone, and we can see our kind of southwesterly wind here. We in meteorology we give winds names according to where they come from, which is a bit strange. So this is a southwesterly wind because it's coming from the southwest. If we go up another couple of kilometres, then we can still see we've got a cyclone, we've got our southwesterly wind, but you can kind of see this is now becoming part of something a little bit bigger, right? You can see the wind going up here. There's kind of like a ribbon of strong winds coming across the Atlantic and then moving up here, right? And if we go up a little bit more, you can see that this pattern really strengthens. Okay, so the winds that we've got moving over the UK are really part of this big kind of band of winds that are going around the planet, right? And so this is essentially the jet stream, right? It's people talk about it being like a river of air or a strong current of air, and it's basically blowing kind of around the planet from west to east. So we haven't really done ourselves many favours in terms of terminology here, right? Because we've got two very different things that we've kind of given quite similar names, right? So the Gulf Stream was the little ocean current that's basically off of Florida. So that's seawater moving in the ocean. Whereas the jet stream here is this whole kind of river of air, and its strongest here is about 10 kilometres up in the atmosphere, and it's encircling the whole planet. But we get so much confusion coming from these names. This is the jet stream as opposed to the Gulf Stream in the ocean. So I have a few more pictures here of kind of real data. or mostly real data. We have a lot of satellites and things these days that can measure lots of things in the atmosphere, but we often need to kind of fill the gaps between the satellite data. So whenever we look at real data, it's kind of a lot of satellite data and weather balloons and things like that, but the gaps have been filled by a computer model as well. So this is a picture of the jet stream for what I've called a kind of a normal year. Right, this was a fairly boring winter, to be honest. So 2008, 2009, and what's shown here is basically the average wind for that period. It's from December to February. So December 2008, and then January and February 2009. And again, we're looking quite a way up in the atmosphere, about 10 kilometres up in the atmosphere. So it's roughly where planes fly, right at that kind of level. So a lot of planes would come from the US over to Europe, trying to follow the jet stream here. Right, this would be quite a good tailwind. Whereas if you're going back the other way, you'll often skirt around it to the north, so that you avoid it. You know, going that way, it'll be quite a strong headwind. So this is kind of what I've called a normal year. The jet is the key thing is that the jet has quite a tilt, right? So the wind isn't just blowing straight across here. There's quite a tilt. It's blowing kind of northwards here, right? And so over us, that's what gives us our southwesterly winds. And so that is largely, so the result of this 2002 paper that I mentioned is that actually it's the fact that the jet is tilted like this, and it's basically bringing us warmer air from a bit further south. That's largely what's keeping the UK warm in winter, not the ocean currents over here. So that's a normal year. We've had quite a lot of interesting years lately, which was kind of part of the motivation for the book. So this was 2009-10, which was the year that this satellite picture was taken, with the UK completely covered in snow. I always like showing this picture because my hometown is Weymouth, down in Dorset, which is just on the coast here, and you can't see it. I can barely see it, but there's a little triangle of green at the bottom there, right? And so when my parents were on the phone saying there's no snow, nothing's happening. But yes, it was a very unusual winter. So you can see now, instead of pointing up like this, bringing us our warm air from the south, the jet stream was really shifted south, and it just went all the way straight across over the kind of Mediterranean and North Africa, right? So the whole of this winter was dominated by this pattern, right? And instead we got some light winds coming down from the north instead, right? And so that's basically why we had such a severe winter. It was also the first of one of the drought years. So I don't know if people here remember this. This was the Thames water warning, I think, from spring 2012. Because there have been a string of very dry winters in a row. Okay, and 2009-10 was the first of these dry winters, and so yeah, people were really seriously worried about drought here in the Thames Valley. Of course, as soon as they put these up, right, summer 2012 was then the wettest summer on record. So yes, they were right to be worried, but in the end, something came to their rescue. So maybe just one more example. I don't know if people remember this image of the railway tracks hanging over the seas. We had a winter, so winter 13-14. We just had a huge number of storms coming at the UK. It was just storm after storm, and these basically followed the jet. That's another thing the jet does, is it guides cyclones or storms. And so in this winter we had a very strong jet stream, and it was straight, and it was just pointed directly at us. And so we just had storm after storm kind of following the jet along here. So hopefully I've kind of given an impression that the jet stream is hugely important for regional weather and climate, right? And a lot of the kind of unusual weather that we've had, and a lot of the most extreme weather that we get, and not just in the UK but around the world, a lot of that is essentially associated with variations in the jet stream. So part of the motivation for the book was try to explain what's happened in some of these events, and there are lots of questions really out there as to how much things are changing. Right? Are some of these events happening because of climate change, and how is climate change interacting with this? I guess I won't say much here because there's a lot of stuff to go into there. But I guess I'll say that there's a lot of uncertainty at the moment. When we look at global temperatures, right, we can tell the world on average is very clearly warming very quickly, and we know why. It's because of greenhouse gases. When it comes down to regional changes like this and changes in the jet stream, there's so much more uncertainty about what's happening now and what's going to happen. So the book kind of discusses some of these things as we go on. So this is a picture from the book. Actually, the idea is that the jet stream actually kind of spirals around the hemisphere, right? So if you're going to try and identify a start, it kind of starts down here in the Caribbean, and then it goes over Africa and over Asia, across the Pacific, but then by the time it gets back to the Atlantic, it's kind of a little bit further north, and so you get this kind of spiraling pattern around the hemisphere. So the book is kind of set up following this basically. So these are some of the places that are discussed in the book, but it follows this route, and the jet stream really changes as you go along here. So for example, it goes right over Everest. It just kind of grazes the top of Everest. It kind of barely affects the jet. But one of the key things is that by the time the jet has reached the Rocky Mountains, the jet itself is very different. It's a lot deeper. It kind of comes all the way down to the surface. And it's actually the Rocky Mountains that are really instrumental in giving us this tilt. Right? So the fact that we get warm southwesterly winds and the jet is tilted across the Atlantic is largely due to the Rocky Mountains, which kind of set up this wave downstream. So that's kind of where that story ends now. So it's not the Gulf Stream that keeps us warm in winter. Bizarrely, it's actually the Rocky Mountains mostly. Okay, so I think I'll stop there. That's the book, and yeah, thanks for coming.